Hello everyone, and welcome to the video tutorial on vector components. So, as you've probably gathered from working with graphing vectors, you've noticed that the accuracy that's offered from graphs is very limited when you're drawing to scale and estimating with a ruler, so on and so forth. So, a method for much more accuracy when adding or subtracting vectors is using components. So what do I mean by components? Well, let's say we've got a vector, and we'll call this vector A. This vector is actually made up of two different components. Okay, so you've got an x component, we'll call that AX, and you've also got a y component. Okay, so let's come up here. We'll call that AY. All of that together gives us our original AX. So, just A, vector A. So, we've got AX and AY here. And we've also got an angle right here. We'll call this angle theta. Okay? So if we look, here's a little bit neater example of it. We've got a vector, we've got our AX and our AY components. And we've got an angle here from the x-axis. So, how do we use this? Or let's start with an example first. So, let's say we've got a vector D, and its magnitude is 3 meters, and its angle is 45 degrees below the horizontal. Okay, so below the horizontal, so we've got an angle or a vector D, and it's coming down from the horizontal at 45 degrees. So how do we find our dx component and our dy component? Okay, well, what we're going to use is trigonomic, there it is, relationships. So, using what we know about right triangles, dx equals d cosine of angle theta. Now, dy is d sine of theta. This all comes from the SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We know what the hypotenuse is. The hypotenuse is 3.00 meters. They gave us that in the magnitude. So to figure out the x component, if you're using the 45 degrees, you've got adjacent dx over your hypotenuse 3 equals cosine theta. So some simple algebra gives you dx is d cosine theta. Dy, we do the same thing. Here we're going to use sine. Opposite is dy is also over here too. Opposite over hypotenuse. So dy is sine of theta. Now, what do we call theta? Because if you look at this, y should be negative. So this angle is 45 degrees, but if you actually came all the way around, you would actually have 360 minus 45 degrees. Okay? What you can also do, dx is d, we'll go d cosine. You can actually also go negative 45 degrees. Okay, this will give you the same answer of 2.1 meters. Now dy is the sine of negative 45 degrees, which gives you negative 2.1 meters, which makes sense. Because if you look, you're going in the positive x direction, and you're going in the negative y direction. Okay? Now you could have also plugged in 360 minus 45, gotten 315. If you use 315 in here, you get these same answers. So, how do we add vectors using components? Well, let's look at an example. Let's go back to our vector A here, and let's add to it another vector. Let's add vector, let's just do vector B. So if we do vector B's components, let's put in his Vx, or Bx. So he's really actually right about there. And then we'll put in his y component, which is right about there. Now, to draw a resultant vector, we would go from head to tail, the head to tail method. So we bring in our resultant vector and connect the head to tail, so right about there. Now, if you look at this vector's components are the red plus the blue y components, and its x component is the red plus the blue components. So we add vectors in the same way. So say we've got a vector A plus a vector B equals some vector C. Well, what we'll do is we'll add up the x components and we'll add up the y components. Okay? Now from here, we've got our vector and we've got our x component, and we've also got our y component. Blue's kind of hard to see. Sorry about that. So let's call this C, and here we've got Cx and Cy. So say we know the components of C, but we don't know the magnitude. Well, to find the magnitude of C, we use the Pythagorean theorem, taking the square root of both of our components squared. Pretty simple enough. Now, what about this angle? Call it theta. Well, theta, we're going to use the tangent relationship. Theta is going to be the arctangent of Cy over Cx, your components. Okay? Now, let's look at an example of this. I'm actually going to get this started, and then you are going to bring it. So, let's say that you have you've got three vectors. You've got, let's call vector A is 72.4 meters, and it is 32 degrees east of north. So let's assume if you've got XY coordinate, you've got north, east, south, and west. Now, you've got another vector, vector B, and let's go with it as 57.3 meters, and it is 36 degrees south of west. And let's do one more vector. It is 17.8 meters directly south. I want you to find the resultant vector of A plus B plus C. Okay? And bring that to class with you tomorrow. And I hope you enjoyed learning about working with vector components.